I'm so mad about that.
Okay, let's do some related rates. So this time we're going to use chain rule and implicit, but we're going to take the derivative with respect to time. So a lot of times now they're going to say the rate of this doing something and the rate of this doing something, and both of them are part of the problem, and you have two variables changing with respect to time. So if we started out with just like a regular function, y equals 5x squared minus 6x plus 2, and I want to find the rate of dy dt when x is 4, and they give you the rate of dx dt, then here's what you do. You take the derivative implicitly with respect to time. So this would be 1 dy dt equals, and then the derivative of this is 10x dx dt, because it's with respect to time, so we have to put a dt with every single variable that we take the derivative of. So minus 6 dx dt, and then the derivative of 2 is nothing. Okay. And it says find dy dt when x is 4, given that dx dt is 2, so we can plug in 4 for x, 2 for dx dt, and then get me the answer to that. So what is the change in y? 58 or 60? 68. Okay, cool. Got it?
Yes.
All right, that's easy. But now we're going to add in the word problem stuff to it. So the hardest part is making an equation. So here's what I want you to do. So we're going to do this one. We have a 6-meter ladder leaning against a wall. Okay, so we always want to draw a picture of what's going on first. So we have a picture of our ladder. Here's our ladder right here. And it's leaning up against a wall. So it makes a right angle. And it's a 6-meter ladder, so 6 is right here. Okay. And then the bottom is being pushed and pulled at a constant 0.5 meter per second. So let's go with 1. Do you want to go pushed or pulled? Pushed. Okay, so let's cross pulled out. So we'll say pushed in at a 0.5 meter per second. Okay. Is this side getting smaller or bigger? It's getting smaller, right? So if it's getting smaller, we're going to go with negative a 0.5 meter per second, because the rate is, the x is getting smaller, so we want the rate to be negative. Okay. How fast is the ladder top sliding? So we want the rate of this. Okay, when it reaches 5 meters up the wall, so y, let's say this is x and this is y, when y equals 5. But 5 is, the y is moving and the x is moving, so we don't want to put that in our equation because those are both moving. Okay, so this 1/2 meters per second is the change in x, so we'll call that dx dt. And this right here, what we're trying to find is the change in y, so we're looking for dy dt. Okay, so basically that's the situation of what's happening. I'll give you a visual. You ready? Here we go. Ladder is moving. So the x is being pushed and pulled at a constant rate, but notice that the y is like super slow at the top movement, and then it gets super fast down here, right? But the x is moving at a constant rate. Okay, everybody got a visual?
Yeah.
All right, we assigned variables. We did our problem. Now we need to make an equation. Yeah, well, if y is positive, we'll know that it's being it's being pushed up, and then if y is negative, we know that it's being pushed down. So we'll do like a double arrow here. Okay, all right, now let's make an equation. My equation has to have x and a y in it. So what should I make? An equation with x and y that visualizes this picture.
X squared plus y squared equals 6 squared.
Cool. 36. 6 squared. 36. Okay, so my equation can only have variables that have the rates, the one that I'm looking for and the one that I have. It can't have any more variables than the 2 rates that I know and that I'm looking for. Okay, now I've made this equation. The 36 I can plug in because that is 6 the whole time, right? It doesn't change. But I can't plug in the 5 here because the y is moving and the x is moving, so we don't want to plug it in yet. Okay, now we can take the derivative with respect to time, step 4. So this is 2x dx dt plus 2y dy dt, and the derivative of 36 is 0. Cool? All right, I can plug in -1/2 for, I don't know what x is yet. I can plug in -1/2 for dx dt. I can plug in 5 for y. And then I need to solve for dy dt, so we'll keep that as our variable. And then I need to find x here. So we go back to our original equation. And we go, okay, if y is 5, what does x have to be? X squared plus 5 squared equals 36. 36 minus 25. X squared equals 11. So we'll put in square root of 11 here. 2 root 11 times -1/2. Okay, so we solve and we get -√11 plus 10 dy dt equals 0. And so our change in y over change in time is -√11 over 10. Units, meters per second. So, Aiden, that's what you were talking about. Oh, positive, thank you. That's what we were talking about. If it comes out positive, we know y is growing, and if it comes out negative, we know y is shrinking. Easy?
Yes.
Yeah.
Oh, why did we choose this circle equation?
What circle equation?
Oh, wait.
Oh, no, it's Pythagorean theorem.
Okay, never mind.
That is, I mean, they're all related.
Yeah.
Pythagorean theorem and equation of a circle.
So does the positive and negative not matter
Well,
in this scenario? Because you're
in this scenario, could, but if we choose, if the problem says pushed, then it does matter. But in this scenario, I gave you the choice.
Flipped the visual, right? So that everything's flipped. So then in that case, pushing it would be +1/2 if we try to go to the center. Because we're going from left to right instead of right to
Yeah,
left.
it would be more specific. It would be like pushed into the wall, and then you would know that dx dt is negative because x is getting smaller.
But even so, because like as you go around that point, it like approaches the same speed, so wouldn't it just not matter overall?
No, it matters because if it's positive, your rate is shrinking or growing, and if it's negative, your rate is shrinking.
Okay.
Your variable's shrinking. Yeah, we'll do some more, and then tell me if you don't get it after we've done more of these. Okay, we're gonna do another triangle one because these are not too bad. What? Next Thursday. But we're done. This is like the last thing of the unit. Okay, we got a winch with a height of 20 feet. This one is 20 feet high.
I think you should find honestly.
And it reels in a rope at 2 feet per second. How fast is the boat moving? So we have a rope down here. We've got a little boat. What's a winch? I'll show you what a winch is. and it's reeling in a rope. How fast is the boat moving when the rope is 5 feet long? Okay, this 20 doesn't change. Should I let's make these X and Z, okay.
It's not long.
Right. So is 2 feet per second my dx dt or dz dt? No, it's not dx dz. It's something. Okay. What's the rope?
The rope is DZ DT.
Okay, you need to see a visual. Let me show you. You don't even know what a winch is, guys. This is the winch. This is the boat. And it's going in like this.
What happens if that's on an exam and we don't know the which?
I don't know.
If we ask, will they go to tell us?
They won't tell you. Okay, so what is 2 feet per second?
This one.
Okay, let's go back.
Would you rather have this?
This is going in at 2 feet per second, and that's dz dt. Positive or negative 2?
It is DZ DT.
Yeah, it's dz dt. It's negative because Z is getting smaller. Okay. How fast is the boat moving? Then if I'm looking for how fast this boat is traveling, we are going to call that dx dt. That's what I need to find. Okay, so that's what I'm searching for. Okay, we set up an equation. X squared plus 20 squared equals z squared, right? And so my equation only has x and z in it, which is good because those are the only rates that I know. You should not have an equation with any variables of rates that you don't know. So this is 2x dx dt, that's 0, equals 2z dz dt. Okay. All right, I know x is, what do I know x is? Do I know x?
You know the
Five.
No, I know the rope is 5.
But if Z is 5, then the boat's not in the water anymore?
Maybe.
Yeah.
Is that an option?
Because that's a negative.
Oh yeah.
We can
That's
just attach
not-
the top on
Can we just make it 20?
25.
Just don't worry about it.
the boat. Wait, what? Okay. You know, because you have to have the top. Yeah, but
Like,
you
you
have
just
to
change the value to 25.
Yeah, we changed it to 25. My problem doesn't work.
It'll make more sense anyway.
So what are we doing? X, right?
Yeah.
15. Oh, that's a nice triangle. Okay, so it's 2 times 15. I don't know dx dt equals 2 times 25 dz dt times negative 2. So dx dt is, there's 2 cancels.
Sorry about
Negative 10 thirds units, feet per second. Okay? Got it?
Got it.
Okay, those are easy. Triangles are always easy. So let's do a cone.
Oh, okay, never mind. Yeah.
Circles, cylinders.
Okay, so water is flowing into a
I feel like
cone.
cylinders is the most common.
You think cylinders is what they usually use?
I feel like that's what most of our problems were.
I agree with that. And cones though? They just never do the
That's still
triangles because they're too easy.
It's still a triangle, isn't
Oh, height of 16, radius of 4.
it? It's still a triangle.
Do they give
It's still a
extra points
triangle,
if our
yeah.
drawing looks really good.
Yeah.
Yeah. Water's flowing in at 2 centimeters cubed per minute. So it's going in at 2 centimeters cubed per minute. What is that? Use your units. Centimeters cubed is volume.
So it's
Minutes
the
is
rate of
time.
volume.
VdVdt. Because that's volume. Okay. How fast is the water level rising? So if you've got water in here,
Oh, it's because
It's DHT.
rises.
right? So there's like little water in here. You're looking for this. dHdt.
Good job, man.
Yeah. Okay, how fast is water level rising? Okay, let's begin. Let's start with volume of a cone. Volume of a cone is, yes.
Why do you know?
Well, it's a cone, and anything that comes to a point is a third of like the cylinder. So a third of a cylinder is pi r squared h, and then it's a third of it. Same thing with like a pyramid.
On the exam, are we gonna get like a formula sheet?
What?
On the AP exam, are we gonna get a
I think they tell you this on the AP exam if you need
I
it.
feel like they gave us a formula.
Yeah, I think they do.
And
Okay.
sphere, I think.
Yeah, it's sphere, which we'll do next.
Is that 4/3?
4/3, yeah. 4/3 pi r squared, pi r cubed, yeah. Okay.
That one I know.
Here's the problem, guys. Remember how I told you you can't have variables in that don't have rates, that one that you're looking for and the one that you have, right?
Yeah.
We have to change.
So we've got to change and we've got to get rid of R
Yep.
because I don't have a rate for that and that's not what I'm looking to solve for. So somehow R's got to go away. So use your knowledge of, are you going to hate me? Similar triangles. 416 to do like a similar triangle in here.
It's not too bad.
So, yeah, 4/16 is equal to R/H, right? So,
I haven't done these.
what should we, am I replacing R with H?
Yeah, that makes sense.
So R is equal to 1/4 the height, right? Yeah? Okay, so now I can replace this R with 1/4 H, and my equation only has H's in it and V's. Yeah? No, we don't have to do product rule because I can simplify it to this, right? And then I don't have to do product rule, which is nice. Okay, cool. Now I have an equation with just V and just H, so that's good. Now I can take the derivative. So dV dt equals 1/16 pi h squared dH dt. Right, because it's 3/48. So it'd be 1/16. Yeah? Okay, so we plug in +2 because water's flowing in, so V is growing. So 2 equals 1/16 pi, we wanted to know when it's 5 centimeters deep, so pi times 5 squared. So dH dt is 2 times 16 divided by 25 pi. I'll just give you 0.407. What will be our units? Height is in centimeters, right? And then time is in minutes, so we go centimeters per minute. Okay? Okay, you try this one. But notice that it says diameter is 1, and it's asking how fast is the radius changing. You didn't see the visual of this cone.
Can I?
Yeah, here. Here's your cone. Phil.
Fancy.
Yeah, that was fun, right?
It was cool.
Yeah.
So like for like the similar triangle thing, like that's like, are we just supposed to kind of like figure that out by ourselves as we move through the problem?
No, I mean, most of the problems are similar now, so you might see another one that is a cone. Just know that it's like,
So, like,
know
so
from
there's,
now
like, a
on
certain
that it's
type
similar.
we should know, like, how to do
Yeah.
it, right?
We're gonna do another similar triangle on number 4.
What is the formula for volume of a sphere?
4/3 pi r cubed. Let me give you the other one. This balloon is kind of fun. Have you seen a spherical balloon before? Do you know those punching balloons?
Yeah.
I feel like those are the most spherical. Actually, they make those Mylar ones that are now round, right? I'm just talking to myself, guys.
Kind of.
Here's your balloon. What'd you get? Good. 3.183. 10 divided by pi? Yeah, I would leave it as 10 over pi. Okay. Did you get it? Does anybody need me to go over it? Gabe?
How's volume 10?
Because it says it's inflated at 10 centimeters cubed per second,
Okay,
and
so-
use the units to help you. Centimeters cubed is in volume, and then seconds is in time. So that would be.
So the volume just to be the rate, it's not like actual volume.
No, it's not volume. I didn't plug 10 in for volume. I plugged 10 in for the DVDT. Because volume didn't matter. Like once you took the derivative, the volume, the V went away.
I got one more supplement. I wrote
Okay,
7
let's do two more. A fish is reeled in at a rate of 2 feet per second from a bridge. So we still have a triangle here. And then reeled in at 2 feet per second, so that's this. So we'll call this Z. And dz dt equals -2, right? Feet per second. From a bridge that's 16 feet above the water, so this is 16, that stays still. At what rate is the angle between the line and the water changing? So, oh, here's our fish. Okay, line and the water changing, that's this angle right here. Theta. Okay, and we want the rate of the angle, so we want d theta dt. Okay, so that means I need an equation that has theta and z in it. Sine, yeah. Sine theta equals 16 over z, right? What's the derivative of sine? Cosine theta d theta dt equals, let's make this 16z to the -1. So then it would be -16z to the -2, right? dz dt. Okay. I got this triangle. Here's theta. Here's 16. And we want to know at what rate is the angle between the line and the water changing when there's 20 feet of line out. So this is 20, right? So what would this side be?
12.
Is it 12?
I think it's a 3, 4,
3, 4, 5, yeah. Okay, do I actually have to find, because this is where a lot of people get stuck, do I actually have to find what the angle is? No, I just need to know what cosine of the angle is, so I can replace all of that. You don't actually have to find the angle, I just need cosine of this angle. So what is cosine of this angle? 12 over 20. d theta dt equals, z was 20, right? -16 times 20 to the -2. And then you know dz dt is -2. So we can figure out d theta dt. Can somebody check me? Uh, 7.5. Did you guys get 7.5? And then theta is in radians, so we go radians per time is in seconds, so rad sec. Radians per second. What?
This is
Rad sec.
this is for the
Did you not get that one?
Yeah.
Oh yeah, that's right. I did it the wrong way. Thanks. What'd you get? 2 over 15. Thanks. That's a lie. Okay. Let's do one last one together. So, last one, a man 6 feet tall walks at a rate of 5 feet per second towards a light pole, 16 feet tall. Here's the man. He's 6,
Dude, I'm already.
and the light pole is 16.
I'm not.
You got it.
When the man is 10 feet from the base of the light, so we'll call this
Help me out.
Would. Dude, I am so tired.
Everyone else has the
At what rate is the tip of his shadow moving? So we want this.
Same here.
So we'll label that
Well,
No.
no.
Z.
Yeah.
I don't even know who I am.
I can predict things you can't see.
I don't even.
And then he walks at a rate of 5 feet per second towards a light pole. So we'll call this right here
Sort of
inside
like-
X.
Actually, then.
Because he's walking towards a light pole. So what do we have? We have dx dt is -5, right? And we want to know dz dt. Okay, so we're going to do a similar triangle again, Ryan. So I can go z over 16 equals, how do I get this little part of the triangle?
Zero.
Yeah, z minus x over 6. Yeah? Okay, now we take the derivative. This would just be 1/16 dz dt equals, we can pull out a 1/6, and then this would be dz dt minus dx dt. Okay, we need to solve for dz dt, so we plug in -5 for dx dt. So we have 1/16 dz dt equals 1/6 dz dt minus or plus 5. So if I subtract, I gotta subtract this over to this side, right?
Wait, why did the 1/6 not apply?
Oh yeah, 5, 6, thanks. Okay. So dz dt, yeah. Units, feet per second. That's that one. The other one is different. So at what rate is the length of his shadow moving? You have to set up a new triangle. And this is 6 and this is 16. This is still x because you know dx dt, but this time you're solving for this length y. That one's a little bit easier because you can set up the ratio x plus y over 16 equals y over 6. And then you're just solving for dy dt, the length of his shadow moving, not his whole tip shadow. Okay. 5. Did anybody get this answer? What?
I kind of just labeled that.
I didn't do it either.
I'm just gonna guess.
You're gonna leave it like that?
Yeah, I'm not doing it. Well, I just guessed it.
It's -3
That's what I got.
My mentor knows.
feet per second. I'll stick with
probably
you.
not like to do
Tell me if it's wrong. Okay, that's related rates, guys.
Yay!
Good job.